In this video, you will learn about gateways and route tables that are used in networks. We have already seen that when we set up a network, we specify the CIDR for the network. For example, if I were to call this as network 1 and network 2, I'm setting up two networks, I might very well go and choose the CIDR for these networks as per my need. For example, I have set up 192.168.0.0/16 as the CIDR for network 2 and 10.0.0.0/16 for network 1. Given that this is the CIDR for both these networks, we also know there could be subnets within them. Each network would have its own subnets. We will not worry about it. For now, let's say there are various computers in my network 1 as well as network 2, and let us say that the IP address assigned to these computers as an example is 10.0.1.100 and 10.0.2.200, whereas on the right hand side I have 192.168.2.2.1.201 and 192.168.1.121. Given that these are the two IP addresses for these two computers, there are more. Each will have its own computer IP addresses as such. Now, please remember, a computer within a network might want to talk to another computer within the same network. It will have the connectivity in place because they are all within the same network. Whereas, if a computer in one network wants to talk to a computer in another network, first of all, we need to have the connectivity between these two in place. In order to enable connectivity between networks, we make use of gateways and route tables. So these enable inter-network communication. To help you understand this, I'm going to put up a simple example of how this would work. So right now, assuming there is no inter-network connectivity in place, a computer in network 1 would not know how to reach network 2. So to do this, we can set up what are called as gateways. For example, I might set up a gateway. I will call it as gateway 1 and gateway 2 in the respective networks. And I've called them as gateway 1 and gateway 2. Having created the two gateways, I will now enable a cable to connect these two. Once I have done this, I now have established connectivity between the two networks. Now also remember, there might be additional networks that are available and each network might have its own CIDR. Remember? So let's say I have network 3 and network 4, and the CIDRs for these networks are 10.1.0.0/16 and the CIDR for network 4 is 10.2.0.0/16. We have ensured all the four networks are having a unique CIDR. None of them are going to overlap. That is a prerequisite before we connect them up. And in each of these networks, I might set up a gateway as follows. And by doing this, I have got, for example, gateway 3 and gateway 4. Now, with the two new gateways I have, I will be able to interconnect these two networks. Now, if I want network 1 and network 3 to talk, I would have to set up a gateway again here and a gateway again over here, which I will call as gateway 5 and gateway 6. And by doing this, I can interconnect these networks also. Now, if you take the case of network 1, which will be our point of discussion going forward, network 1 has got connectivity with network 2 as well as network 3. But when a computer within the network wants to talk to another computer, it needs to know which gateway to take. A simple way to understand it is, if you have roads that are taking you places, you might be going on a road to a particular destination and you land up with an intersection. Now, these roads are similar to gateways that give connectivity to different destinations, and when you land up with a particular intersection, if I have to call this as an intersection, what do? You generally look up in a signboard that might be set up. So you have road signs which will tell you where will you go if you take a left or a right, assuming you are coming in this direction. Similarly, in a network, when a packet needs to go to a particular destination and the network has multiple gateways, it needs to know how or which path should it take, and that is the idea behind route table. So in network 1, I will set up a route table which is required to identify the path to go. For example, in the route table, I might say use gateway 1 to reach 192.168.0.0/16, whereas I might say use gateway 6, that's what I have, to reach 10.1.0.0/16. Given that I have made the two entries for the route tables in network 1, when a packet which is originating from within one of these computers and this computer wants to send a packet, let's say a packet in this computer which is 10.0.2.200, and this packet you want to send it to a computer over here, it will first look up into the route table and identify that to go to 192.168.2.201, it knows it needs to take gateway 1. So it will go into gateway 1 and arrive in gateway 2 into the other network, and it will reach this. So gateways give the connectivity, whereas route table gives you the lookup to identify which gateway to go. Now, it is also possible I might have another entry in my gateway, which could, in my route table to be more precise, which could tell something like this. In the same route table RT1, if I say use gateway 6 to reach 10.2.0.0/16, then the packet that is going to go out of my network will go into gateway 6 and gateway 5 and enter this network. But we will assume there is a route table in place in the other network which will divert that traffic through this gateway and take it to this gateway and reach a computer in this network. So this is what is the purpose of gateways and route tables. Generally, this information is kept in routers so that it can decide how to route packets between networks. Keep in mind, route tables are generally not required when you are talking to computers within the network, but they come in very, very handy when you want to communicate across networks. Now, when we talk about this, we also need to understand something called as a longest prefix. For example, if I have a route table for a network which says use gateway 1 to go to 192.168.0.0/16, and I also have another gateway which I say use this to go to 10.0.0.0/16, and I also get a gateway 3 which says 192.168.1.0/24. Now what you must notice is the two gateways seem to have an overlapping CIDR. If you note it, 192.168.0.0/16 is actually a superset of this. But given that there are two gateways given in the route table, whenever a computer with an IP address within this range is reached, then the gateway that will be used to reach that is gateway 3, whereas any other IP address within this range other than what is given as 192.168.1.0/24 will be reached using this gateway as such. So route tables can have multiple entries, various gateways, which basically act as signboards as to which path to take. Gateways are the paths, route table are like signboards, which enables packets to go through. Now, does it mean that every computer in a network should know all the gateways? Not necessary. Whenever a computer sends a packet, it will look up into the network and automatically route itself. Thereby, it is not necessary that every computer knows how to reach its destination upfront whenever a packet is sent. The packet will identify it by looking up into route tables. So that's the idea behind gateways and route tables in a network.